lesson is about function notation. And I'd like to start with just a little kind of a warm-up question. So I want you to go ahead and pause your video and do this for me right now. Okay, so let's look at this. When x is 0, okay, I've got y equals 2 times 0 plus 1, and that equals 1. When x is 1, I have 2 times 1 plus 1 is 3. When x is 2, I have 5. And then when x is 3, I have 7. Okay, so hopefully you got those answers. And just set them aside right now. I'm going to write them up here so we don't forget what they are. But we're going to use those in a couple of slides here. So function notation. I hope you've got your notes out. So get ready to write it down, because here it is. It's coming. There it is. That's it. I don't know if you've had this before. It's basically just that y is the same thing as f of x, and that's how we say it is f of x. Okay? So not too hard. All right? So why is this important? It's important because it gives us added information. And let me show you what I mean by that. So this warm-up we have, what answers did we get? Well, we got 1, 3, 5, and 7. Could I graph this function with those answers? Could I go, okay, graph 1, graph 3, graph 5? I mean, I could try, they would be lines, but I really can't graph coordinates because I don't know what my x value is. Okay, so when we are writing in function notation, instead of, I gotta go back here, instead of y equals 2x plus 1, let me come back now to where we were. Okay, instead of y equals 2x plus 1, we have f of x equals 2x plus 1. And remember, we wanted to know what it was when x was 0 and 1, 2, and 3. And so now what we do is we say f of 0. Okay, instead of just plugging it in here, I put it here too. And it doesn't do anything. There's no computation of any kind. It's just telling me that at 0, it is 1. Okay, f of 1 is 2 times 1 plus 1, which is 3. F of 2 is 2 times 2 plus 1, which is 5. And we know these already, but I'm just showing you in function notation. 2 times 3 plus 1 equals 7. So, can I graph it now? If I don't have, say I don't have this. Say all I have is this. Okay? This tells me that this coordinate point right here is 0, 1. It tells me this one, f of 1, this is my x value, this is my y value. Okay, here's my x value, so I know what it is that I've dropped in here. And there's that one. And finally, we have 3 and 7. So 0, 1, 0, 1, 1, 3, 2, 5, and 3, 7. This is actually a line. Okay? But function notation tells me which values of x I'm putting in to solve for. All right, so let's look at this. Evaluate f of x equals negative 4x plus 7 when x is 2 and when x is negative 2. So it's just exactly what we did, except for instead of y, I have f of 2. So put x in, put 2 in for x, and I have f of 2 equals negative 4 times 2 plus 7, and that is negative 8 plus 7, which is negative 1. And if I put in f of negative 2, then I have negative 4 times negative 2 plus 7. This is 8 plus 7, which is 15. So what this is telling me is when my x value is 2, my y value is negative 1. When my x value is negative 2, then my y value is 15. All right, so I want you to try this one. So go ahead and go ahead and pause your video. All right, so let's see what we have here. If we're plugging in negative 4, so f of negative 4 is 2 times negative 4 minus 5, and that is negative 8 minus 5 is negative 13. F of 0 is 2 times 0 minus 5, which is negative 5. And finally, we have f of 3, which is 2 times 3 minus 5, which is 6 minus 5, which is 1. Okay, so over here, we have g of x, so we're going to have g of negative 4 equals negative, and x is negative 4. So a negative 4 minus 1, well, a negative 4 is a positive 4, minus 1 is 3. G of 0 is negative 0, which doesn't really exist, minus 1 equals negative 1. And finally, g of 3 is negative 3 minus 1, which is negative 4. Okay, so we're going to talk a little bit more about that, about function notation in the next video.